members, to help you with your GCSE prep, we're doing some practice questions. Today I picked a question from the IGGY physics test, higher level. This question is about astrophysics. In particular, it starts out discussing the Big Bang Theory. Again, as we're looking at these problems, make sure that you read the questions thoroughly before you begin in the exam. This question starts out saying, observations of the spectra from distant galaxies provide evidence to support the Big Bang Theory. Part 1 tells us to complete the following sentence. Many scientists think the Big Bang Theory describes the blank. This is something you should have learned in your physics courses, and the Big Bang Theory is a popular theory which tells us about the origins of the universe. So what they're looking for here is to complete the sentence by saying the origins of the universe. So that's part 1 done. Part 2, again, we're still talking about the Big Bang Theory. It asks us to tick one box to complete the sentence. So again, we're completing a sentence here. This is testing your knowledge of the theory behind the problem. The sentence reads, the discovery of cosmic microwave background radiation was important because it, and you're given 3 options. It either proved the Big Bang Theory to be correct, it provided more evidence to support the Big Bang Theory, or it proved the universe will continue to expand forever. Now there's a couple of key things to watch out for here. In physics, and in science in general, it's very difficult to prove things. We can build evidence and create very strong theories, but it's very difficult to prove beyond a shadow of a doubt that this is the way it was, especially with something like the Big Bang Theory, which happened billions of years ago and no one was around to actually record what happened. So therefore, the best answer here is the second one, which says provided more evidence to support the Big Bang Theory. And that's what they're looking for in this particular problem. So we move on to part 3 of the problem. Part 3 of the problem now begins a discussion about binary star systems. They give you some information about the systems. It says many stars are part of a binary star system. Binary star systems have 2 stars. And then it talks also about the visible spectrum from the stars, which include dark lines. And these are observed from Earth either through telescopes or the Hubble can also detect some of these. And what they're asking for here is what name is given to the effect shown in the spectrum from star A. So we're given 2 drawings here in the problem. One is a diagram of what a binary star system looks like. Binary star system is 2 stars that orbit each other around some fixed point. It's not necessarily in the middle, but in this diagram they put the point basically in the middle between the 2 stars. And then it shows the path of orbit. It's also given us very simple spectra diagrams. We've got the sun, which is our sun, and then a comparison with star A and star B. And then it tells us that the wavelength is increasing to the right. Star A has then a slightly longer wavelength than star B or our sun. So this tells us that the light coming from star A has a longer wavelength, and it could mean a variety of things. But in this instance, what they're trying to get you to understand here is that star A is moving away from you, which would be a red shift, which is red is towards the longer wavelength part of the visible spectrum, or also known as the Doppler shift. So the correct answer here would be the Doppler shift, or Doppler effect. But another acceptable answer is called redshift. So either one of those should be fine. The final bit is a bit of writing, and it basically says that they've come to the conclusion that these 2 stars are in a binary star system, basically from comparing the spectrum to prove the evidence. And I want you to explain how they've been able to come to this conclusion. Again, going back to the wavelengths that were shown previously, we've got a redshift from star A, but we also have a shorter wavelength from star B, which would indicate the opposite motion here. Since it's shorter than the sun, so we can assume that we're roughly at the position of the sun, our point of observation, we see star B kind of moving towards us. So that would indicate to us that we've got star A and star B moving like this. And eventually, what they would see is a shift in that spectra. So a good answer here is to say, we know star A is moving away from us, star B is moving towards us, and they're at the same point in space. So it's a good indication that this is in fact a binary star system.